So I'm going to talk a little bit about how to prove two triangles are congruent. I'm going to go through the steps here without, well, we'll see how it works out. Okay, so the first thing I want to do here is I'm given these two things, that BC is congruent to DC and AC is congruent to EC. I'm going to mark that on the diagram just so I can keep track of it. So BC and DC are congruent, we'll mark those with one hash mark, and AC and EC are congruent. Mark that with another hash mark. First thing I'm going to do is I'm going to say I'm trying to prove that BCA and DCE are congruent, the two triangles, so this triangle and this triangle. What am I going to use? What theorem am I going to use? Well, I've got two sides, and then if I look here, I've also got these two angles, vertical angles. I know that those two angles are congruent, so I can use side, angle, side. So let's just write that over here, side, angle, side. First pair of sides I've got are BC and DC. Okay, and I've got my reason. How do I know that they're congruent? Well, I know they're congruent because it tells me right here. Yeah, it's one of my givens. So I will just write over here. I'll write. I know it because it's given. Right. Okay, angles. Which angles are congruent? Well, these two right here. I don't want to call them angle C, right, because angle C could be either one of them, and it could also be this angle down here, it could also be this one up here. So I'm going to call it by its full name, so I'll call it angle BCA. Remember, BCA, go around the angle. The vertex is always the middle letter. And that's congruent to angle DCA, or DCE. And I could have called it ECD or an ACB. It doesn't matter what order I go in as long as C is in the middle. How do I know those two are congruent? Well, what do I do here? I know these two angles are congruent because they're vertical angles. So I can just write vertical, and I'm going to write, instead of writing angles, I'm just going to use that angle symbol. Okay, and then the last pair of sides, I've got AC and EC. So AC is congruent to EC. And that's given also. That's one of the things I was given right here. Okay. And then from those three statements, I can conclude that, therefore, triangle BCA is congruent to triangle DCE. And the theorem that I used was side, angle, side. This is a basic, it's called a two-column proof. You're going to see this you're going to see it in a slightly different form sometimes, but this is an important thing for you to know. The way it works is that I've got two columns. That's the name. On this side, I have my statements, the things that I'm using to get to my final thing, my proof here. On this side, I have my reasons. So each time I say something, I use something I'm using to get to my final statement, the thing I'm trying to prove. I have to give the reason for it, so I give the reason over here. The last statement is always going to be what I'm trying to prove. So I'm trying to prove that triangle BCA is congruent to triangle DCE, so that should be right here, and it is. Okay, let's try another one. Number 2. Okay, again, let's mark what we know. JK is congruent to LK. That's one of our givens, so that those two are congruent. JM is congruent to LM, so those two are congruent. And what else do I have? I need one more thing to show that the two triangles are congruent. Well, I know that KM is congruent to itself. And I mark that, even though it's not like there's something that matches with it. It just helps me to keep track of everything. Okay, so again, JK is congruent to LK. And I know that because it's given. It's one of my givens. I know JM is congruent to LM. Also one of my givens. And the last thing I know is that KM is congruent to itself. So KM is congruent to KM. Right? And how do I know that? Well, in general, you'd say I know it because, well, it's the same thing. It's congruent to itself, obviously. In math, we refer to that as the reflexive property. And in this case, that's the property that everything is congruent to itself. Everything's the same length as itself, same height as itself. Okay, so I've got side, side, side. And I use those three to prove that triangle KJM is congruent to triangle KLM. Again, note that's the thing I'm trying to prove. I can put my little therefore symbol there if I want to make it really fancy. And I know that that's true by SSS, right? Because I'm side, side, side. And again, I can kind of, after the fact, go in and make it look like a fancy proof. My statements, my reasons. All right. Last one. Apologize for the line across the middle here. Okay, given GFH is congruent to IFH. And the other thing that's given is that FM bisects GMI. So that should say FH bisects GHI. Well, here's GHI. And bisects, what does bisect mean? It means cuts in half. Cut in half. And if you cut, so it's cut, FH is cutting GHI, this angle here, in half. If you cut something in half, what do you end up with? Two equal pieces. Okay, so these two angles, GHF and IHF, are also congruent. Oops. That's a little easier to see. Okay, now I've got two angles. I need something else. I need a side somewhere. I've got this side here. Okay, that side in the middle, and it's the side between the two angles, so I'm going to use angle, side, angle. Now let's write up the proof. This time I'm actually going to write my statements and reasons. I'm going to write it like I've got my two columns. So the first thing I've got, well, what do I know? I know GFH is congruent to angle IFH. That's given. Another thing I got FH here is congruent to itself, right? So FH is congruent to FH. And that, again, that's called the reflexive property. Congruent to itself. Everything is congruent to itself. Then I've got GHF and IHF. Well, how did I get that? I started with what was given, that FH bisects GHI. So FH bisects angle GHI. That's given. And then I use that to say that, well, then angle GHI is congruent to GHF is congruent to angle IHF. Remember I said, well, it bisects it, so it cuts it in half. So these two have to be equal. And I got that just from what bisects means. So all I used was the definition of bisect. What does it mean to bisect something, right? That's all I used. Okay, now what do I have? I got my angle, I got my side, I got my angle. So I can say that triangle GFH is congruent to triangle IFH by angle, side,